In this lecture, I am going to explain about elimination of useless production. By this word itself, we can able to understand that in grammar there are some production which is of no use. So those type of production is called as useless production. So I am going to explain this elimination of useless production with example. Question is written over here. Eliminate useless production from the following grammar G, and grammar consists of four parts. One is set of variable ABCD and set of terminal, that is sigma. Set of production rules starts from here to here. Start symbol S is A. So I am going to remove useless production from this grammar. Removing useless production means I'm going to remove unwanted production, the production which I'm not going to use throughout this grammar. In this example, there are some production which is not used throughout derivation. So those productions we are going to remove here. So whenever I want to derive any production, I'll be starting from start symbol. In this example, start symbol is A. So I'm going to start from start symbol. So I'm going to start here. So first, so I'm having for A, I'm having two A production. One is A tends to AB, another one is A tends to 0. If I choose A tends to 0, I got terminal here. So this will be my useful production. So at the end, if I get terminal, then my production is useful production. So let me start with next option, that is A tends to AB. So now I am going to derive this production. So instead of A, I have two options. Either I can substitute A tends to AB or I can substitute A tends to 0. So let me substitute A tends to 0. Hence my production will be 0B. Now instead of B, I have to substitute B production. So if I see B production, there are two B production. One is B tends to BC, another one is B tends to 1. So if I substitute B tends to BC, then my production will be 0 BC. For deriving, either we can use rightmost derivation or we can use leftmost derivation. So I am going from left to right, so I am using leftmost derivation. So instead of B, I am going to substitute B production. So if I check B production, I have two B production. One is B tends to BC, another one is B tends to 1. So now I am going to substitute B tends to 1. Anyone I can substitute. So I am going to use B tends to 1. So now I got 0, 1C. Now I am having non-terminal C. So instead of C, I have to substitute C production. I have two C production. One is C tends to CD. Another one is C tends to 1. So I'm going to choose C tends to 1. So instead of C, I am substituting 1. So I'll be getting 0, 1, 1. Now I don't have any non-terminal to substitute. So I got input string. So let me rewrite the productions which I used for getting this input string. Simultaneously, I am writing useful productions here. So after removing useless production, then the grammar G dash will be V suffix in set of variables used and terminals used here. So in this case, I have used 0 and 1. So 0 and 1. And start symbol is same as like question. So start symbol is A. So let me write the productions which I have used now to get this input string. So I have used A tends to 0, then I have used A tends to AB, then I have used B tends to BC and B tends to 1. Also I used production C tends to 1. So I'm left over with some two more productions, C tends to CD and D tends to D0. So let me check that productions as well. By using useful production, we could able to derive input string. So those type of productions is called as useful production. So let me start with the productions. That is, I'm going to start with start symbol here. So whenever I want to derive any input string, always I have to start with start symbol. So I'm going to start with start symbol here. So my start symbol here it is A. So I'm going to choose A tends to AB now. So instead of this A, either I can substitute 0 or I can substitute AB. So it's up to me. So I'm going to substitute A tends to 0. So I got 0b. Now instead of b, either I can substitute b tends to 1 or I can substitute b tends to bc. So already I have checked that these productions are useful productions like A tends to AB, A tends to 0, B tends to BC, B tends to 1. So directly I'm going to substitute B tends to BC now because I want to check whether C tends to CD and D tends to D0 is useful or not. So hence I'm going to substitute B tends to BC. So as I already know this B tends to 1 and B tends to BC is useful production. So I don't want to check further. Hence I am going to substitute B tends to 1 now. So I'll be getting 0, 1, C. So now I want to check C tends to CD. So instead of C, I'm going to substitute C tends to CD. Now I have two non-terminal C and D. So instead of C, either I can substitute C tends to CD or I can substitute C tends to 1. So if I substitute C tends to CD, so it will continue again same thing. So I'm going to substitute C tends to 1 now. So I got 0, 1, 1D. Now I'm going to substitute D production. So I'm having only one D production. So I'm going to substitute D tends to D0. Again I'm having non-terminal as D. So if I substitute D, I have only one D production, that is D tends to D0. So instead of this D, I have substituted D0. So if I substitute again D, I will be getting D0. So I will not get any input stream here. So I will not get any yield for this production. So if I substitute C tends to CD, I have to repeat this again and again. I couldn't able to find any solution for this production D. So because uh, I don't have any terminal for this D production, hence this production C tends to CD and D tends to D0 are useless production. So I'm going to remove that production from this grammar. After removing useless production, my grammar G dash will be like this. So I'll be having three non-terminals A, B and C and two input symbols 0 and 1 and start symbol will be A and productions are A tends to AB, A tends to 0, B tends to BC, B tends to 1 and C tends to 1.